Hello, my name is Rafiq Wayani. I'm here to discuss Docker technology with you. More specifically, I'm here to simplify Docker to you. The thing is, many times technology, when explained by certain individuals and organizations in presentations and PowerPoint slides and large seminars, and sometimes even by industry professionals, it may be confusing to someone who is not technical. I'm going to try my best to explain Docker technology and what Docker is in a very simple form, and even give you a demonstration of what it is, so hopefully you'll understand it a little bit better. Here goes. We went from physical machines generally to virtual machines, and we then moved into the cloud environment, and then we moved into containers. Well, the thing is, going from physical to virtual machines was a massive shift in paradigm. And then going from virtual machines over to cloud environments was another paradigm shift. And then going to containers was another shift. We understood the move from physical machines to virtual machines very easily, because virtual machines made it possible for multiple servers, virtual servers, to exist on one physical infrastructure. At one point in time, you needed to have one physical infrastructure for one application. Virtual machines took care of that very nicely, because now, whether something was on your machine, in this case it's showing a laptop, or you had your data center, on-prem data center, or you had it in the cloud, essentially referred to as infrastructure, because this infrastructure points at the RAM, processor, network, disk, and other resources that are needed for applications to run. Let me put it to you this way. A single server, let's say this was a HP server or a Dell server. Let's say it was on-prem at your location, home or workplace or data center or wherever it may be. On that server, you would place what is called a hypervisor. Hypervisor really took the physical infrastructure, RAM, processor, disk, network, and other resources, and made it possible to put multiple operating systems on there, multiple virtual operating systems on there. These virtual operating systems were files. Essentially, the responsibility of the hypervisor is to take those files and translate them in such a way that they behave as though those hardware elements and hardware components, RAM, processor, disk, and network, and USB and mouse and keyboard and video and all of that other stuff, behaves as though it is on that virtual machine. So on one server, one Dell server or one HP server, you had, for example, VMware, or you had, for example, Microsoft Hyper-V, or you had Citrix, let's say. You can put the Windows operating system on there. You could put, for example, a Linux OS on there. Maybe this was Windows 2016 and maybe this was Windows 2019. You could put multiple operating systems on there. And the thing is, each of these guest OSs, as it's called, the reason it was called guest OS is because hypervisor was the host OS, VMware, for example. And without getting into too much detail, this was the complete guest OS, complete, full guest OS. So if you installed Windows Server 2019, it was a complete Windows Server 2019, as if you were doing an installation on a physical machine, nothing direct. And on top of that, you would install perhaps the libraries that would communicate with the guest OS. In the case of Hyper-V, that is integration services. In the case of VMware, that's VMware tools, for example. And those binaries, those libraries, made it possible for the guest OS to communicate really, really easily with the hypervisor. There were other things in those binaries as well, other than just communication with the host OS. On top of that, so you would have your guest OS, like Windows Server 2019, let's say, or Windows Server 2016, let's say, and then you would put a web server, and then you would put a mail server, and then you would put a database server. So essentially, on one hypervisor, on one infrastructure, you would put multiple virtual machines. That's really where virtual machines were a huge benefit. But there was a problem with this particular setup. And that problem was that this interface, this environment, was still too top-heavy. And what I mean by top-heavy is, in the security-conscious world, in this rapidly changing technological universe, the time that it took to build this OS and to move it into production was, well, quite a bit still, in the big scheme of things. Also, from a security perspective, if someone hacked this guest operating system, essentially Windows or Linux, whichever version of Windows, whichever version of Linux was running on there, if someone got in and hacked that, they would essentially have free reign of whatever this application was. Okay? So, well, that means that the vulnerability of the guest OS still applied. Not only that, it was possible for the vulnerability of this guest OS to lend itself to other guest OSs. If all of these machines were the same exact OS, they were all Windows Server 2019, potentially they could all be hacked, because those are complete OSs with service packs and hotfixes and security configurations on them, but still it's a complete OS. So, this web server, this mail server, this database server was a complete web, mail, and database server with a complete guest OS, whatever OS it was sitting on, Windows, Linux, Windows or Linux, a version of Windows and a version of Linux. So what is a developer supposed to do? Think about that for a minute. A developer would have to get this hypervisor on their desktop. Well, they can. If they wanted to develop, they did have the ability to get the hypervisor on their desktop. It's called a Type 2 hypervisor. Oracle VirtualBox, VMware Workstation, for example, VMware Player, for example, fit really nicely into that puzzle. But the desktop needed to have resources, or the laptop needed to have resources, lots of RAM, and you still had to worry about managing that guest OS while you were developing. Okay? You couldn't just start it, stop it, move it, and so on. And now your laptop, let's say, that was sitting at your desk, needed to potentially have 16 gigs or more of RAM, because you would have on that laptop a guest OS that would be perhaps running your Active Directory, that would be running your web server, your database server. So that laptop had to be very beefy, for lack of a better word, if you were doing development. Or you needed an entire environment, an entire lab environment to host that or those virtual machines. So to help with the development aspect, Docker containers came out in 2013. Containerization as a whole, believe it or not, has been around in someone's mind since the 70s and the early 80s. 1982 was the first time containerization was realized. Yes, that long ago. It didn't come into the form that we're looking at today until 2013, but it's been around for quite a long time. You can look that up. I'm going to spare you the history lesson. So what happens is that unlike the virtual machine, which had the complete guest OS, we have our infrastructure. We still have our HP or our Dell server. That doesn't change. We have an operating system, which can be Windows or it can be Linux. On top of the operating system, we place a container engine, which largely was Docker. There are others. Red Hat has their own Podman, for example. And there's another one called Rocket, but Docker largely. Okay? Now, things change here. I have the container engine, I have the operating system, I have one or the other. I have Windows or I have Linux on top of my infrastructure. I have Windows or I have Linux, not both. I have the Docker container engine, and then I have some bins and some libraries that communicate with the container engine, and then I have the application. The thing is this application, this web server, this database server, this mail server does not have the complete guest OS whatsoever. It just has the most minimal component required to make the database server, web server, and mail server run. Most minimal components. Also, containerized universe are also known as headless servers. And the reason they're known as headless servers is because there is no graphical interface that you can use to get into this particular database server, web server, or mail server. It's the clients that are using them, or the developers that are developing on them, or the management components that allow you to interact with the containers. That are graphical. So for example, if these containers happen to be, let's say the container happens to be a Active Directory domain. Okay, let's say this is a Active Directory domain, for example. Let's say this is a DNS server, for example. Let's say this is a SQL server, for example. The container would not be graphical, but if you had a Windows machine, you could use SQL Server Management Studio graphical interface to communicate with that database server. If you had Active Directory users and computers, ADUC, you could use that to communicate with that Active Directory domain. If you had a DNS management graphical interface, you could use that to communicate with that container. It has a very small footprint, very small attack surface, and it can start up, shut down, expand, and shrink on a whim very quickly. Let me get to the demonstration part, hopefully so I can show you how easy it is to start, stop, essentially provision containers, and how easy it is to build multiple containers rapidly, start them and shut them down, versus these VMs. To start, stop, essentially create start and stop VMs takes a lot more effort. Takes a lot more effort on part of the operating system, on part of the resources required for that VM to run, which is not the case with containers. Containers have something called images, and container images are very similar to, synonymous with, virtual machine templates. VM templates let you build virtual machines. Container images let you build containers. Container images, one image, allows you to build and run, essentially, multiple containers. Let me show you what I'm talking about. Here I've got a Linux machine. Essentially, I have a Linux box that is a CentOS Linux version 7 in this particular instance. And I've got this Linux box with Docker already installed. When I say Docker images, I have this image here called Nginx. Nginx is a web server. Think of Nginx, for our intents and purposes, as if it were a Windows IIS, Microsoft IIS server. Microsoft IIS server is a Internet Information Server, which is a web server on Microsoft's side. Imagine if I had a virtual machine with IIS installed on it that I can deploy to other virtual machines. So imagine I had a virtual machine template with IIS loaded on it, ready to be deployed to a VM. This right here is an image of Nginx. Nginx is a web server. Let me show you how easy it is to deploy this web server. So what I'm going to do now is I'm going to run, if I do Docker images, Here's my Nginx image. Remember, Docker container image is the template. I'm going to say, I'm going to use Docker run. The reason I use Docker run is because Docker is the command. Docker is a command. Headless server means I'm going to type in a command to execute or run this image. It's essentially like deploying a virtual machine. I am going to run this image, and I'm going to run it in the background. D is detached. I'm going to run it in the background. I'm going to name it web1 because it is going to be a web server. I'm going to give it a host name of web1. Well, here's the thing though. This name right here, this web1, is how I can use to reference it when I'm using Docker. This host name web1 is going to be how the image will be referenced within itself. So this is the running instance name, and this is the name that will be used to reference by Docker, the command line. Okay? And then I'm going to say I want to open port 80, and I'm going to map it to port 80. To the left of the colon is what the port I'm mapping or publishing on this host. This host is a Linux machine. The host that is hosting this VM is a Linux machine, or this image is a Linux machine. Container image is a Linux machine. To the right of the colon is a port inside of the container. So the container is going to be running the Nginx web server, and this is going to be the port 80 inside of the container. When it's running, is going to be mapped to port 80 on the host. The host in this case is Linux. Okay? And I'm going to be executing Nginx. And there it goes. This right here is a long container ID. Container is a running instance of Nginx. Running instance of Nginx. Let me show you something. If I do docker ps all, ps is processes, if you will. Here it's telling me that it is running. It's been up 16 seconds ago. The name is web1. Okay. And it's telling me that it has mapped port 80 on my machine. 0000 is this machine. And it's mapped it to port 80 inside of the container. Watch what happens. If I check the IP address of this machine, it is 10.0.0.177. Let me show you something that I think you're going to find amazing. So when I do 10.0.0.177, here it is. It says, welcome to Nginx. You can see right here that web server is running. Let's say you don't believe me, right? Let's say you think this is something that I did already. Watch this. I'm going to go over here, and I'm going to say docker exec in interactive mode. I'm going to go into web1, and I'm going to open up bash. Bash is the Linux shell. Web1 is what I named my container. Interactive mode, and I'm running the bash shell. Here I am inside of the container. Look, it's called web1, which is what I named the container. This is the name of the running version of the container, and this is the host name. Docker 01 is a host name of my machine, my Linux machine that is hosting the container, in this case the web server. Here's what I'm going to do. I'm going to do user shares Nginx HTML. All right, and then I'm going to say, watch this, I'm going to say echo h1 Rafiq says hello from web server, like that. And I'm going to put this in lovely simple HTML. There we go. Now, if I go here and I do a refresh, look, Rafiq says hello from web server. So if you notice in this instance, I go up here, I can change this to whatever I like. Rafiq, everyone says hello from this web server. refresh. There you go. Okay. Now, what I want to show you is, right here, if I exit, I exited the container, and I am now back on my host. Okay, I exited the container, I'm now back on my host, and this host is Docker 01, which is my Linux host. So if I do this, if I say Docker ps-all, which is is going to tell me the running processes. So right here, as you can see, it tells me that that's the name of my, that's the container ID. That right there is the port that I'm mapped to. That is a container that I'm running. Kind of powerful, you know what I'm saying? So let me show you something else. If I say Docker, I'm just going to go back to this command here. I'm going to change this to web2, change this to port 81. That's the second one. 82, web3, third one, web4, fourth one. And now, when I do a Docker ps-all, I've got 4 web servers running. I have one mapped at port 80, port 81, port 82, and port 83. All of them are mapped to port 80 on the inside. They're mapped to port 80 on the inside, but mapping to port 80, 81, 82, 83 on the outside. So watch. If I change this to / if I do :81 / welcome to Nginx. 82, welcome to Nginx. 83, welcome to Nginx. Just to show you what I can do. See these names here? Web4, Web3, Web2. Watch. For bash. I'm going to do user. And I'm going to go into share. I'm going to go into Nginx. And I'm going to go into HTML. And I'm going to use echo h1. This is web server 4. h1 index HTML, exit, and refresh. Click. 4th web server. So I can change and manipulate. If I go back to the first one, that's the first one. Okay, and that's how easy it is for me to have 4 web servers going. Now, the beauty of this is that I can kill all of them just like that. Watch what I'm talking about. If I do a Docker remove force Docker ps-all q, and that makes all of the web servers go away. If I do a Docker ps-all, nothing is running anymore. If I go back here, it's just going to spin and spin and spin and go nowhere. As you can notice right here, it's spinning. It's not going to go anywhere. There you go, unable to connect. So that's how I started them, stopped them, manipulated the index HTML so you could see how it was hosting the pages, and I killed it very quickly. To summarize, what I ended up doing is I ended up running on my infrastructure, I was running Linux. And on my Linux happened to be CentOS version 7. I was running the Docker container engine. And I ran 4 web servers. Not 3, I ran 4 of them. I started them, showed you how I got into them and got out of them. The whole thing was run in a headless manner. The headless part being that I was actually running the Docker command line, right? It was a command line interface that I was using to run this. So I started and stopped, essentially removed everything very quickly. You can turn on and turn off whatever features you like. You can turn on and turn off storage. You can turn on, turn off networking. You can turn on, turn off management. You could really do whatever you want. You can make them as secure as you want. You can start them, have them run a task, and then disappear before anybody has a chance to gain access to it. It has a very small footprint. It is more secure and it uses a lot less overhead. So that is a summary, introduction, of containers. Yes, I did it in a hurry, and I included a lot of information. I hope you saw something that you hadn't seen before, and hopefully some of the information clicked. I'm really glad you're here. Please comment and let me know what you think. Have a great day.